Hey guys, this is Morteza and I'm an assistant professor at the Electrical and Computer Engineering Department at the University of Utah. Welcome to Microelectronics Design Automation Lab channel. Today we are going to talk about how to write a paper basically, and we are going to uh, dig into the structure of a good paper. We're gonna have another video talking about like how to write paper, like how should we think and what are the steps. But here we just want to focus on like the structure of the paper. So um, we basically this is a template that I have created. So the main sections usually are we have an abstract, we have an introduction. These are like the two important and necessary sections, uh, as well as conclusion. So conclusion is the last section usually, and abstract and introduction are the first two sections of the paper. And then we have like some sections in between that we talk about uh, kind of the background and related work, as well as our methodology and evaluation, basically our result that we're going to show. So let's talk about each of these sections one by one. For the abstract, um, okay, before talking more, I just wanted to mention that the template and my explanation is mainly for um, computer engineering papers. It may not be completely suitable for like a nature paper or like a paper in another field, but mostly, usually with this template, we can get a very good, impressive present representation of our work. So, okay, so let's get started. So the first section here, the first thing that we are seeing is a title. Having a catchy title, it's very, very important. Uh, Basically, we're going to talk more about that later, but uh, trying to find a name for our tool, for our work, it is very, very useful. It makes that the reviewers and all other people, when you're going to talk about that, they can understand, they can remember what we are talking about. And we should have like enough um, explanations, information for our title, and we should make sure that it's not like very, very long, so it's not something like uh, 5 lines. But usually, um, for like our cases, usually it is good to have like kind of between 2 and 3 lines. So here is an example of it's one paper that I have published during my PhD. It's about an analog circuit generator using neural network. So it's circuit design automation, but it has been published in kind of more like a circuit, IEEE TCAS 1, which is like more like a circuit journal, but again um, the same structure. We have published it in many computer engineering conferences and journals as well. So there's not like a big difference. It is more like about like our general area, which is the circuit design, automation, and computer engineering. So, um, okay, so basically this is our title in this example. So this is the name of that angel. Okay, it's basically for sure, it's a catchy name, and it's like a positive catchy name. Um, Sometimes there are many stories about like how like finding like naming their tool or their paper something that is not like super positive. How I have heard many stories about that, how that thing negatively affected the result of the paper. For instance, like I remember one person named their tool COVID, and that was like a little bit before when the COVID started, but when it was under review, it was during the COVID time, and it didn't really get that much good positive feedback about that. Okay, that's one point, that like having like a kind of a catchy and positive kind of name. So this is like one of the example of that. Angel, we have another tool which we call it Phantom. Um, that is again like another like kind of positive uh, uh, name, because it we meant that like our tool is very fast or something. And this is Angel, it's positive again. It's like because it's an Angel, it helps us, and all of these details. But the other thing basically is, if we can try to find kind of like abbreviation in this between the words, that would be kind of make it a little bit even cooler. We don't have to do that. The name of our tool shouldn't be like an abbreviation, or like a great abbreviation of our title. But if we can find something that would kind of add a little bit more zing to it. So here, as we can see, basically Angel is like for analog, the A and N of analog, GE of generator, and L for learning. So as we can see, like there are many words that we haven't included. I mean, because we didn't want to have like a very like a long name for that. And more important, we didn't want to like change the order, or like change the main purpose of having a title, which should summarize what we are going to do, just to have like a very cool abbreviated name. But again, like we should first like talk we should first think of a good name that summarizes basically our work, that when the reviewer sees this title, it completely get it complete when the reviewers look at our title, they completely get what our tool is supposed to do. So basically here it's clear that okay, it is automated, it is for analog circuit generation, so it's an analog circuit generator, and basically it uses a neural network. Okay, so that is the kind of the main important here. And because we wanted to uh, emphasize that we are trying to decrease number of training data, we have mentioned this semi-supervised learning approach. Just basically just to not have only like a neural network, because neural network, when we published this paper, it was kind of like very famous. So just saying that okay, this is like a um, automated analog circuit generator using neural network, that wasn't like make it quite different, even though that wasn't like a problem with that. But adding this like specific thing basically that we have here, like assisted semi-supervised learning approach, it makes it a little bit more unique basically again. All right. Uh, so after finding a good catchy name, we first see an abstract. So abstract is basically title and abstract and introduction. These three uh, sections in exact the same order are the most important part of our paper. So even though that we spend most of our time when we are working on a project, basically we work on this methodology, correct? We we propose ideas, we try to implement that. So basically, like 90% of our time is spent usually on basically in implementing our approach, which we will talk about in methodology section. But in terms of the reviewer's perspective, um, the reviewers, this is like a kind of sad fact. They don't spend usually more than 5 minutes on your paper. So a paper that you have maybe spent 6 months, 8 months to implementing that, probably like 2, 3 months, 1 to 2, 3 months to writing a paper out of that. The reviewer spent usually a reviewer spends like 5 to 10 minutes, especially for conferences, which is like kind of the most important venues for our cases. So we don't have that much like a good journals except one, um, which is like IEEE TCAT, or like this IEEE TCAS one. We have, because we work on circuit, yeah, we have some good ones, but uh, it's more catchy for us to publish in usually like conferences. And the conferences are like each reviewer usually they get I don't know, like 10 15 papers, and they are like professors, they are very, very busy. They have their own papers, they have a lot of other stuff. So they really don't have that much time to spend. So this is our job to convey what we have done in a way, basically in more precise way, in the most precise way, that in that 5-10 minutes we give a very good positive impression to the reviewers. So basically that's how reviewers read usually a paper. They look at the title, they read the abstract, and believe me, until then they usually they have 70% have made their decision that if they want to give a good or a bad point to this paper. Again, for the journals, usually the reviewers they have more time. So for the journals, I mean, usually they have like 2 months kind of to review a paper. So they take a better look into that. But even for that, it's very, very probable that they don't spend more than 10-15 minutes. Okay, so basically the reviewer look at the title, they look at the abstract, and as we mentioned, they decide kind of 70% with 70% confidence that if they want to pass or reject this paper. The rest, that 30% left, usually like 20% is spent on introduction, kind of, to little bit get more that what how we have implemented, like what uh, how we could um, fulfill the promises that we have made in the abstract. And honestly, like 5-8%, they take a quick look into the tables and figures and kind of maybe 1 to 2% on the how basically we have implemented. So basically, usually it's like after in the abstract, they kind of, as we mentioned, they kind of are decided to proceed or not. If we don't give a good abstract, if we don't give an impressive abstract, we are done. That means that like our paper is gonna get rejected. But if we do a good job in abstract, we're gonna motivate the reviewer to read more. Okay, so again, it doesn't mean that, okay, if they read more, they still will like their paper, but for sure it means that if we don't do a good job in writing abstract, we won't, we will lose our chance. Even though if we have like a very good problem, if we have like a very good implementation, they really won't spend time on that. Okay, so let's talk about abstract. Okay, so usually basically I'll start with an introduction about the importance of problem. Okay, that why we are looking at this problem. Like usually something like, okay, there are many use cases for this problem. For instance, there are many use cases. So I usually, for instance, for circuit design automation, I start with saying that like manual circuit design is very time consuming and there is a huge need for circuits, so we need to have a circuit design automation. So basically this is kind of the importance of a problem. The Okay, but this is like too general, and we need to little bit support more what is the importance of our problem that we are targeting in this paper. Circuit design automation, it's like a general field that, okay, we talked about that, but we want to more precisely talk about the issues basically. So we go to the second point. What is the issues with current approaches? What has made the current approaches not good, basically? So, for instance, we can say that something like, okay, the previous approaches, they are very slow, they don't have a good accuracy, and so on and so forth. Then we talk about our proposed solution, our proposal, basically. We say that, okay, we uh, want to do to solve the aforementioned issues, we're going to propose, for instance, like Angel tool, and because of 1, 2, 3, our Angel tool works. Okay, so we're gonna quickly, like in mostly like 2, 3 four lines, we should say that, okay, what is our approach? That our approach, for instance, has used neural network, has used semi-supervised learning, and a little bit more information that how can we solve the problems that the previous approaches had. Okay, this is just like give a quick glance that, okay, that we can do that. This is like how in high level we can solve the problem. And the last point in abstract is usually reporting our results. Okay, so we should usually report it in both absolute and, but more important, in comparison, and mention it as times format. It means that if we say that our accuracy is 95%, okay, that is good, but it really doesn't have that much meaning, because what the reviewers want is how much could we improve the previous approaches. Okay, so by saying that our accuracy is 95%, that doesn't have that much meaning, because, okay, the previous approaches, their accuracy might be 100%. Okay, so what have we improved? But if the previous approaches, their accuracy is, I don't know, like uh, 70%, 80%, and our accuracy is 95%. So it's good to say, okay, our accuracy is 95%, which is, I don't know, like 1.3, 1.4 times better than the previous approaches. Okay, that 1.3, 1.4 times more, that is kind of the catchy part for the reviewers, that they want to say, okay, how much could we improve, basically. So, uh, usually, because we don't have that much space, uh, if we have some numbers that we can compare, usually it's better only to, in the abstract and introduction, it's usually better to talk about that comparison, just saying that, okay, our approach is 1.3 times better accuracy. But if we don't have that comparison number, we can mention the absolute value. All right, so let's take a look into the abstract example basic that we have here for Angel. As we can see, this is like that importance kind of and like kind of an introduction of the basically the importance of the question that, okay, machine learning has shown promising results in predicting behavior of analog circuits. However, in order to completely cover the design space, supervised machine learning requires a large number of label data. Okay, so basically we kind of merge those two. We say, okay, this is like kind of an important task. Machine learning is good, like giving some like introduction, not just jump basically into what's the problem of the previous approaches. Because here we first say that, okay, the machine learning has shown promising result. This is kind of an introduction, but the previous approaches that have used machine learning, that's the problem. They require a large number of label data. Then we're going to build more on that. A separate data set must be collected for each circuit topology. Okay, so for writing these, it's kind of the, you know, how basically we can write these. We're going to talk about this in another paper, in another video more precisely, but it's kind of opposite of like we have created our tool for some purposes, and because of the goals of our tool is whatever the previous approaches were not good at. Okay, so basically we should mention these two at the same time. Okay, we talked quickly about what was the problem of the previous approaches and give it like a quick introduction, and now we talk about our solution. So in this paper, we present a database included and so on and so forth. We use a neural network to determine the behavior of complicated circuit. So we give a little bit information of how basically what is our approach and how it's gonna solve a problem. So here we said, okay, we use neural network. So this is our approach to determine the behavior of complicated topologies by combining the more simple ones. By generating such unlabeled data, the time for providing the training set is significantly reduced. Okay, so we said that how we are going to solve the problem that we mentioned before. that, okay, that the problem was supervised machine learning. They supervised, so they need label training data, and that is very time consuming. Also, they need separate data set, and here we said how we can merge those data set basically together and use unlabeled data. So this is very, very important that for the issues that we talked about that in abstract and introduction, should make sure that we have addressed those issues basically. We cannot say that, okay, the problem of previous approaches were that they were slow, but for saying our approach, the advantage of our approach, we cannot say that, but our approach is accurate. Okay? If we want to say that our approach is accurate, we should say that the previous approaches, they lack of accuracy. Okay, this is very important that we address all of the problems that we have mentioned for the previous work. All right, so moving on, we got a little bit talk more about like our tool, kind of a little bit more information that, okay, what is the main attributes of our work. Angel performs all the schematic circuit design steps from deciding the circuit topology to determining the circuit parameters. So basically, it is like an elevator pitch that you have like 2 minutes and you wanna sell your product. How are you gonna talk about that? That is what the purpose of abstract. Okay, and then we reach to the last part, which is the result. Okay, our results show that for multiple circuit topologies, in comparison to the state of the artworks, this is very key word here. We should always say that, okay, in comparison to the state of the art approaches, what happened? Because if like we compare our work with one work that was published, I don't know, like 10 years ago, 20 years ago, or 50 years ago, that's not that much point out of that. And here we can see that how we have emphasized on comparison, correct? That we have reduced the require label data is reduced by 4 times 4 to, I don't know, 1000 times. Also, the runtime of Angel is faster. Okay, so this is very, very important again to um, report the numbers by uh, time and comparison.